I am Professor Adebayo, and this is Musa. We are here at Grit Hole Studio to ensure you are fully prepared for the UTME Physics exam. Our objective is a score of 90 or higher. To achieve this, we use a methodical approach that prioritizes understanding physical principles over simple rote memorization. We are starting with the first section of the detailed syllabus, Topic 1AI, Measurements and Units. These are the specific objectives the board expects you to master today. First, we identify the unit of mass. Second, we define the unit for time. Finally, we relate fundamental quantities to their units. Proficiency in these objectives is necessary before attempting the more complex formulas found in later chapters. Musa, please do not overlook these basics. Many candidates assume units are too simple to require study, which is a common mistake. Examiners often use these simple units to filter out candidates who rush through their calculations. A typical examiner tactic is to provide variables in non-standard units, knowing that many students will forget to convert them. For instance, you might be given mass in grams when the formula requires a different standard. Similarly, a time interval might be listed in minutes or hours instead of the required seconds. If you plug 50 grams into a formula that expects kilograms, your final answer will be off by a factor of 1,000. That incorrect result will often be listed as option A to catch you early. To avoid this without a calculator, remember that 1,000 grams equals 1 kilogram. Shifting the decimal point 3 places to the left, multiplying by 10 to the power of -3, converts grams to kilograms instantly. In physics, equations are mathematically valid only when you use Standard International, or SI, units. To master these units, we must distinguish between a fundamental quantity and a derived unit. Think of this in terms of how we prepare food. In a local market, you buy raw, individual ingredients: tomatoes, peppers, onions. These are your base components. Fundamental quantities are like these ingredients. They are the base measurements of physical reality and cannot be broken down into anything simpler. Now, consider a finished dish. A pot of jollof rice is a combination of those raw ingredients. It is derived from them. Most physics concepts, like velocity, force, or energy, are the jollof rice of the syllabus. They are recipes created by combining fundamental quantities like length, mass, and time. Without understanding the raw ingredients, you cannot correctly combine them to solve for derived quantities. There are exactly 7 fundamental quantities defined in the UTME syllabus. This table maps each quantity to the specific SI unit you must use in every calculation. Length is measured in meters, symbolized by a lowercase m. We also have electric current, measured in amperes, luminous intensity in candelas, and the amount of substance measured in moles. Temperature requires special attention because of how we use it in daily life. While we use Celsius for the weather, the SI unit for physics is Kelvin. Using Celsius in a gas law equation, for example, will result in an incorrect answer. Learning these 7 pairings ensures you can identify the correct units even when an examiner tries to mix different systems. Let's look closer at objective IV, the unit of mass. Professor, if these are base units, why does the SI unit for mass, the kilogram, have a kilo prefix? Why isn't it just the gram? That is a very perceptive question, Musa. It's a point that confuses many students. Practically, a single gram is too small for most physics experiments and engineering applications. The kilogram was chosen as the standard to keep calculations within a practical range. Now let's address Objective 6, the unit of time. The standard SI unit for time is the second. In kinematics and motion problems, you must always convert minutes to seconds by multiplying by 60. Understanding the practical reasons behind these measurement standards makes them much easier to remember during the pressure of an exam. Let's apply this knowledge to a typical exam scenario. This question asks, which of the following is not a fundamental physical quantity? Our options are length, ampere, mass, and time. Under the time constraints of the UTME, these 4 terms might all seem equally valid. The examiner is testing whether you can maintain a clear distinction between 2 different categories of measurement. Success in this exam requires both the technical knowledge and the attention to detail to notice small differences in phrasing. To solve this, we simply check the wording of the question against our table.
The question asks for a quantity, which is the property being measured. Length, mass, and time are all properties.
They are quantities. That leaves option B. Ampere is the correct answer to select. Ampere is a unit, the tool used to measure, while electric current is the actual quantity. Differentiating between the property and the unit is a consistent way to avoid these types of examiner traps. Well done, Musa. You've successfully navigated the logic of Topic 1AI. To reinforce what we've covered, go to the studio and launch the Topic 1AI video, slide, and quiz to complete your master